Next up, I'm going to focus on name resolution, and it might not be specifically the type of name resolution you're used to thinking about. You may be familiar with DNS, which resolves host names to IP addresses. So when you go to google.com, that's actually just resolving to a specific IP address you can make HTTP requests to. In this case, we're going to talk about that, but we're also going to talk about a couple other types of name resolution. And in this regard, we're talking about things that make Wireshark analysis easier because you're substituting a value that's maybe a little trickier to understand. You're substituting that with something that's maybe a little easier and a little more identifying. So you're not looking at just a string of digits or a string of bytes. You're looking at a name or something a little bit more familiar, which is really helpful when you're looking at streams of data. Now, I'm going to show you a bunch of different examples of this within Wireshark, but I want to go through a couple of them real quickly here on the slides just so you can see what we're looking at and conceptualize this better. Now, in this case, we're going to be looking at things in this format. We have an original value that's just some type of data, and then we're going to take that data and look it up in some type of data source, usually a file or some type of database, and we're going to find the equivalent value. At that point, once we have the equivalent value, it can be substituted in for the original value where it makes sense or where it helps your analysis. And that's what Wireshark's doing when you're enabling or disabling these features. One place this comes into play are with MAC addresses. If you're familiar with MAC addresses, they're used to uniquely identify a network interface, a layer 2 address, an Ethernet address. They're supposed to be globally unique across the world. That doesn't always happen. There are some collisions, but they're generally divided into two halves. The first half, or the first three groups of numbers, are the organizational identifier, and they're assigned by a specific organization. They're going to be unique to that organization, whereas the latter half is going to be just entirely unique. So in this case, we have a raw MAC address, which is maybe not the easiest to remember. You're going to have a hard time remembering 002170CO56FO. That's going to be dang near impossible to remember. But if we take that and look up in the OUI database, we're going to resolve that to what you see on the right, which in this case is a MAC with the OUI information. In this case, it tells us it's a Dell interface, so it's something that was built by Dell, or at least has assigned to their OUI, and the unique part of that is only the last half. So it's Dell C056F0. Of course, if you're looking at this in Wireshark, you can sometimes maybe just reference that as the Dell or as the laptop or as the workstation if it's the only one you're dealing with. So that's a lot easier than calling it by the actual MAC address, which is something you're probably not going to remember. I certainly don't have the ability to remember those, and I wouldn't expect you might either. If you can, more power to you, but most of us can't. Now, another type of name resolution, which we're all maybe a little bit more familiar with, are mapping IP addresses to DNS names. Most of you can probably remember 10.100.12.1, but you probably can't remember that if you're dealing with a packet capture in which dozens or hundreds of other IP addresses are present. It might be a little difficult to remember which system that is. Is that the marketing system or the sales system? Maybe it's the mail server, maybe it's the router, who knows? So if we can map that to a specific name that's a little bit more descriptive, if we have the ability to do that, that's going to help us in our analysis. So we're not having to take that additional mental step of remembering what that is, especially in cases where we have IP addresses that are going to look similar. A lot of our IP addresses might be in this 10.100.12 range. So in this case, you might have a 10.100.12.1, a .10, a .11, a .111, all these different things that are going to look really close and really easy to mix up. So when we have the ability to resolve that to a DNS name or find an equivalent one, that's going to be helpful. So of course the DNS protocol can help us do that, or we can actually use a host file, which is an individual file with manual mappings. But there's one of those present on your system now, and there's one that's specific to Wireshark that you can create too. I'll show you how to do that, how we can create those. But that's how you get from something like 10.100.12.1 to marketing PC1. So again, marketing PC1 in this case is, for the most part, visually equivalent. It's a way to reference the IP address. There's some abstraction there. It's important to know that that abstraction exists because, of course, an IP address can change, whereas the DNS address may point to something different at some point. But for the most part, we can consider these things somewhat equivalent when we're doing our analysis. Now, one last type of name resolution occurs at the transport layer, and it's port name resolution. We know that transmission control protocol and UDP, user datagram protocol, or layer 4 protocols, communicate over ports, and certain numbers of those ports, particularly the ones usually below 1024, are known for having specific services associated with them. So in this case, port 80 is most closely associated with HTTP. Now, HTTP traffic isn't the only thing that can flow over port 80. Certainly many things can, but 99% of the time, unless maybe you're dealing with some type of security scenario or some type of weird custom protocol, the things you're going to be seeing over port 80 are HTTP, just like the things you're going to see over port 22 are SSH, 21 is FTP, 443 is HTTPS, so on and so forth. These things have their commonly used ports. So what we now have is a services file, which basically is a mapping of ports to their common services. So that way, when you're looking at Wireshark, instead of listing port 80 in the info window, you can actually have that substituted for HTTP, and it'll actually show you what that service is. So you can actually reference that instead of 80, which may be helpful when maybe you don't know all the common ports and you need some additional information to help your analysis there. So that's not one I recommend leaving on by default all the time, but we'll talk a little bit more about the pros and cons of that, why it can be a good thing and why it can be a bad thing. So again, these are all just different types of name resolution. And Wireshark provides these to make analysis easier. And basically, when you have the state of things that are equivalent or have the ability to create equivalencies that help you remember things better, that's a good thing. So it's a good thing Wireshark provides these. And we're going to show you next how to go in and turn these things on and off, how to interact with them, how to do some automatic name resolution for certain types, and how to do some manual resolution where it's appropriate as well. So let's not waste any further time there. Let's go ahead and jump in and show you some of those examples. I've got Wireshark pulled up here, and we see we don't have any type of resolution currently enabled. So of all of those different data types I just showed you, we would all be on the left-hand side, that left column where nothing's really resolved. And you can see that really easily just by looking around here. So if we look at the packet that I currently have selected, look in this area, we see that we just see the MAC addresses and the OUI is not resolved. So we don't have Ethernet resolution going on. We can look up here at the port numbers. So we have port 80 listed right here, and it doesn't say HTTP, so we're not doing any type of transport resolution. And of course, we see IP addresses here and down here in the IP section. We see those as well. So we don't have any type of IP resolution. So basically, no resolutions occurring, and that's by design because I've intentionally turned it all off. So the question is, how would we go about turning that on? To do that, we're going to go click Edit and go to Preferences. Once you do that, you'll see that there is a name resolution section, which is the section that's really pertinent to our discussion here about enabling that. Now, by default, a few different types of name resolution are turned on with Wireshark. I've gone ahead and disabled them all. I believe MAC address resolution and transport resolution, the first two checkboxes, are enabled by default, but I've disabled those just to show you the effect that it has. So first of all, let's say that I want MAC address resolution. So I want to resolve the first half of a MAC address to those OUIs so I can see the actual firm that engineered those and that's responsible for those particular addresses. Now to do that, this is a pretty simple change. I'm just going to put a check mark here next to resolve MAC addresses and hit OK. Now you'll see that the screen refreshed behind me, and when I look here at the packet where we're in packet 5 here, we see that on this Ethernet header that we now have a resolved version of the MAC address and an unresolved one. So we see here we have a Dell device communicating with a Cisco device. And as you can imagine, it's a lot easier to remember Dell and Cisco than it is to remember both of these long MAC addresses. Now, that doesn't really help a lot if you have a large capture with a bunch of devices and they're all Dells or they're all Ciscos. But in this case, what this tells me is that I have a workstation talking to a laptop, a workstation talking to a router, because I know that my workstation is a Dell and that my router is a Cisco device. And on my network, I only have one Cisco device. So anytime I see Cisco here, I know it's this MAC address, which I've not committed to memory. And I can use that for making my decisions when looking at those MAC addresses. So that's a really helpful thing. So now that we've got MAC address resolution turned on, let's turn to transport layer resolution. So the ability to resolve ports to their specific representation, so to the specific service that they represent. And I go to this one next because it's another really easy one. We'll once again go into Edit and then Preferences. We'll go to Name Resolution, and the second checkbox is Resolve Transport Name. So I'm just going to click that, hit OK, we'll see the screen refresh behind us again. And in this case, we'll see that instead of just 80, so we have port 52166 talking to port 80, instead of just 80, we now have HTTP, and 80 is in parentheses. So that's pretty cool, and it tells us what service is expected there. Now, it used to be the case with Wireshark that it would fully replace the port number with the name and not include the number anymore. So it would just say 52166 to HTTP. And when that was the case, I didn't really love that because, in truth, a lot of the times, some services like HTTP are pretty much always what you expect them to be, again, excluding security scenarios where things are being intentionally hidden. However, there are a lot of other assignments that Wireshark references that are maybe not so discrete, that are not so absolute every time. So I would see the case where a new analyst would see that, this port is associated with, this other specific service. And then they would just assume that was the case, and they would assume they're looking at that type of traffic, when in fact, it was actually something completely different or something completely random that just happens to be on that port. So it would create this sense of false assumptions, which would introduce some types of confirmation bias, and a lot of bad analysis would result from it. So I didn't really love that. And as a result, I would normally leave transport resolution off, and I would tell everyone else that they should leave it off too. Now that Wireshark is showing these, again, with the name and the number together, I'm a lot more okay with that. I think that makes sense. So as a result, I generally will now have it on, but that's a relatively new development. But nonetheless, that's how you enable transport resolution so you can resolve port numbers to their services. Now, one last thing when we talk about transport resolution, a question I'll get asked often is, where does Wireshark get that information? How does Wireshark know that that port 80 traffic is HTTP? Is that something that maybe is built into the protocol dissector? And in this case, it's actually not. It's actually maybe not where you would expect it to be, but there's actually a specific file that ships with Wireshark, and it's called a services file that contains this mapping of port number to common service. And this is something, if you're familiar with Linux and Unix-based operating systems, most of them have this file as well. And so it's also called services on those as well. And you can reference that similarly, but Wireshark kind of includes its own, which is going to probably differ a little bit from the one that comes with your operating system. We can actually find that and edit it and change it around if we want. Now, the best way to do that, it's located in the Wireshark program directory, which in a default install is going to be on Windows, is going to be in C program files Wireshark. If you're not sure where your program, where your install directory is, you can actually click on Help and go to About Wireshark and go to Folders. And we have the system and program directories here, which in this case are the same thing and are both in C program files Wireshark. So I can actually click on that directly. It's going to open my Wireshark program files folder. I'm going to scroll down here, and you'll see we have a file right here named services. So I'm just going to go ahead and double click that. We'll tell it we want to open it in WordPad. And we'll see this file is pretty darn simple, right? It's just a list on the left of a service name and on the right of a particular transport port along with the protocol. So it may vary based upon whether it's TCP or UDP, but that's where we can come in here and see a lot of these common things. So I can actually scroll down here and in this case find port 80 TCP. And that is going to map to the HTTP protocol here. Of course, in this case, 80 UDP is also going to map to it, but this is what we'd expect. So this is where that information is coming from when we're actually turning on transport name resolution, and this is where that Wireshark pulls that from. Of course, this is just a simple text file, so you can edit this. So I could change this and just replace HTTP and call it web if I wanted to. Right, and in that case, it would change how that's displayed in Wireshark. I'm not going to do that in this case. I can't think of a lot of reasons where I've done this, where I've edited an existing one of these. But there are cases where I've run into a protocol that isn't listed here, or maybe I have a protocol running on a non-standard port, and I want to edit that. So, for instance, HTTP is on port 80, but let's say I'm running a web server on port 7221. I could go in here and actually add an entry for 7221 TCP and call that HTTP as well, right? So I could set up my own resolution that would show that. And that's actually kind of a helpful thing to new analysts if you want them to know about the custom services you have and be able to resolve those to a specific service. You can go in here and edit this file, and that's a pretty useful way to go about that. So Wireshark makes it pretty easy with a lot of these configuration options. If they're not at least directly editable in the user interface, then they are editable in configuration files. And for the most part, that's going to work similarly across some different versions of Wireshark. But that's how you would do it specifically in Windows and in our scenario here. All right, so now let's move past transport names and let's talk about IP resolution. And when we do that, we're talking about resolving IP addresses to domain names, because names are obviously a lot easier to remember than addresses. So we're going to look here again at our name resolution section and look at this third checkbox, which says resolve network IP addresses. And now if I click into here, if I hover over this, it's going to say resolve IPv4, IPv6, and IPX addresses into host names. The next set of checkboxes determines how name resolution should be performed. And that's very important. So we're not just dealing with this single checkbox here. We're worried about these other options here too. And that's important because IP address resolution can be done in a number of ways. And I'll go over those briefly now. First of all, we can use captured DNS packet data for address resolution. We'll talk about DNS more in detail in a dedicated section later, but for the most part, we know that DNS is used. You send packets to a DNS server to resolve a name to an address, right? So if we're already collecting packets that contain this information, then it's pretty cool that Wireshark can actually go in and look at those packets and pull that out and use that to enrich the content you're seeing. So if you have DNS resolution information and this is checked, it can actually go in and read that information. And that's pretty cool. It's very minimally impactful and it's pretty neat. The next option is a little more involved, and it says to use an external network name resolver. So on your system, you probably have a DNS server configured to resolve network names. And so what this is saying is it's actually going to rely on the DNS service to go out and actively seek out resolution information. So what you're doing is that you're actually generating packets on the wire. You're actually generating DNS requests to go out and resolve these local addresses to names, right? And that's a pretty effective way. And if you have access to a DNS server on your network, that's an effective way to gather that information. However, there are a couple of drawbacks you need to be aware of. One is that just by nature, you're generating packets on the wire. And really, one of the goals I mentioned earlier when we talk about capturing packets is our goal is to be as passive as possible. And if you're looking at a security issue or you're trying to troubleshoot a latency issue, the last thing you want to do sometimes is generate additional traffic on the wire. It takes you from a passive participant in your analysis to an active participant, and it's going to muddy the waters a little bit and might have some undesirable outcomes. So that's generally not a good thing. Now, of interest here as well is that if you're using a network name resolver, that's only going to be relevant if you're actually on the network you captured the packets from, right? So if I turn this on, it's going to send out all those packets and try to resolve this. But if you're not on the same network, so if I capture this from one network and move to another segment or go home and look at the packet capture, it's not going to be able to retrieve that information. So it's actually going to fail and not be useful for you. So that's a concern there as well. Finally, you have to be concerned if you're in a very large capture that you're going to generate a ton of concurrent requests. Now, the good thing is Wireshark has an ability to limit this, and you see right here below we have an ability to limit the maximum number of concurrent requests that are available, and here by default it's limited to 500. So I wouldn't want to go probably much more above that, but for the most part, that lets you keep from, creating a denial of service condition and generating way too many requests or more that can be handled. So that's a nice feature there. Generally, I rarely use external network name resolvers when I'm doing captures and when I want to do this type of name resolution. I'll either rely on using captured DNS packet data, or I'll use a manual host file. And I'll talk about that here in just a minute. I'll show you how to do it. But a manual host file allows you to basically set up a manual text file that has mappings of IP addresses to names. And that can be a pretty useful thing as well. Most people, for some reason, seem to be hesitant to do that. It is just a hair bit of work, but it can be really useful when done in the right way. Oh, and one more thing, keep in mind that when you're dealing with PCAP versus PCAP-NG files, a PCAP file doesn't store any name resolution information. So if I tell it to use an external network name resolver or something like that and to perform resolution that way, and then I close that file and then reopen it back up and it's just a PCAP file, it's not going to actually save any of that information. I'm going to actually have to do that resolution process again to get that information. That's important. If you think you're getting that information, you take a packet capture off site, then you may realize when you get it there, you don't have that anymore and there's no way to get it. So that's tripped up a lot of people. Now, PCAP-NG will actually cache that information, so you have a little bit more flexibility there, but PCAP won't, so be aware of that. Now, in this case, I want to pivot over and talk a little bit more about the hosts file, which I mentioned was just a mapping of a host name to an IP address. And every system has one of those by default, and it's a way to provide those mappings manually. But Wireshark also provides one as well that we can use to create our own manual types of resolution. So I actually want to go through an example of that now. So to set up for that, the thing we need to do is to tell it that we want to only use the profile host file. So I'm going to go ahead and tell it to resolve names that way and hit OK. Now it's going to refresh the screen here and nothing's going to happen, and that's because we haven't set up our host file yet. But we're going to do that now, and we're going to do that in a way to very quickly be able to recognize specific hosts. And the ones I want to focus in on here are, let's do this 172.16.0.122 address. Let's say that's an internal system that we're very familiar with. Let's say we're going to call that marketing 4. So we'll go ahead and say that 172.16.0.122 is marketing 4, and we want to be able to reflect that in this capture to help our analysis so we can more quickly spot that machine as compared to other machines. Now let's also pair that with another one, and let's say that this other address here, this 199.181.132.250 is, let's say it's Google. Actually, this is HTTP ESPN. Let's say that's the ESPN web server. So we'll say that's ESPN, and that's the two names we want to resolve. So let's go ahead and look at how we can edit the host file to make that happen. So to make this happen, the first thing we really need to do is create our file, our host file, which will provide the mapping we need. To do that, I'm just going to click down here into the application bar and just open up Notepad. And the format of this file is very simple. We're just going to list the IP addresses that we want to use, and then we'll list the names we want to use right after that. So I'm going to go ahead and do that now, and I'll go ahead and list 172.16.0.122 as the marketing IP, and we'll go ahead and list 199.181.132.250 as ESPN. So we'll go ahead and do that, and we're going to go ahead and tell it to save this. Now, I'm going to name the file hosts, and I'm going to change save as file type to all files because we don't want to give it that txt extension. The file has to be named host. All lowercase has to be without a file extension. If you name it host.txt, Wireshark won't pick it up and it won't work. Now, the file also has to be saved in a very specific location. I'm going to go ahead and paste that location in here. And this is kind of hard to see, but we're looking at user profile. So your user profile directory, this is going to be like C users, C Sanders in my case, but %user profile will get you there, / application data / Wireshark. I'm going to put that in here, and it's going to bring me to that location, and then I can save this file, and we're going to be all set. So that file should be in existence there. It looks like it still gave it this this .txt extension, which we don't really want. I'm going to go ahead in here and click into here and just go ahead and manually knock that off, because again, we can't have that extension or it's not going to work. So now all we have to do is reload the packet capture file. You'll see that the changes we just made aren't reflected immediately, and they won't be. You have to reload the file. You don't have to completely exit out of Wireshark, but we can just click this reload button here on the toolbar, and you'll see once I do that, everywhere where the IP addresses that I've identified appear, they're now replaced with the name I now manually put in place. And that's a pretty cool thing, because now we can see, instead of looking at that IP address every time when scrolling through these packets, we can actually see the name of the device, and in this case, the name of the web server. So that's pretty powerful. Now, as far as recommendations for when and how to do this, I definitely recommend doing this for internal hosts, especially those that are going to have static IP addresses that are maintained well. Hopefully you have some type of internal database that tracks all your sensitive assets or the particular servers that are going to be static in your environment. So your domain controllers, your file servers, your DNS servers, those things. If you have that data already, why not put it in this format and distribute it amongst other analysts or other IT people you may be working with, so you all have a copy of it and it's all on your workstation. So you apply that automatically when you open these captures, so you don't have to spend time hunting down IP addresses, because of course remembering those IP addresses is a lot trickier. I don't expect you to be able to remember hundreds of IP addresses, but if I say domain controller 4, you're going to know that's a domain controller. It may not specifically matter necessarily which one it is, but you are going to know the role of that system, and that's going to help you out a lot when analyzing traffic and seeing things, seeing whether things that you're witnessing are things that should be happening, right? So if you're scrolling through a list of a bunch of hosts and you see a domain controller or a DHCP server or a web server is involved all of a sudden, you can actually very quickly spot that without having to go look up those IP addresses, because having to go look those things up and look up different IP addresses and such is really a drain on your brain as far as going through the analysis process efficiently. Now, in this example, you also saw me mark a web server as ESPN. I don't really recommend doing that, marking external IP addresses based upon what the actual domain is or something like that, because those can change. There is some extraction from that. And ultimately, you don't control that resolution, so that could change very easily. Now, if you are investigating something for maybe security purposes and you're looking at a bunch of maybe potentially malicious IP addresses, you can give those shorter names so they're a little easier to remember. So you might say, malicious host 1 or malware host or botnet C2, giving it some type of descriptive name in that way. Another strategy, if you're dealing with maybe a latency issue, is to name things based upon the office that they're in. Maybe communication between two offices is slow. And you're only dealing with a couple hosts. You can name everything, Albuquerque 1, Albuquerque 2, Albuquerque 3 versus Louisville 1, Louisville 2, Louisville 3, right? So you're naming them based upon location. Remember, this can be just a temporary measure. It's not a permanent measure in all cases. It's just a temporary measure to help you get through the analytic process and help you utilize name resolution really to its fullest ability. So just make sure you're keeping your files up to date, your host file is up to date. Make sure you clear it out when you're done with these temporary things. And you can really go a long way with this. I make very extensive use of host files. I maintain a specific host file for my network assets. So when I open a capture, I know what's what without having to look up addresses. And I highly recommend you do the same. It's probably one of the biggest takeaways I hope you get from this course is the value of host files and how they can help you in the analysis process. Now, keep in mind one last thing when you're dealing with host files, it's going to be stored in a different location based upon your operating system. So in this case, we were in user profile, application data, Wireshark hosts. On OS X, it's going to be users username.wireshark hosts, and on Linux, it's going to be /home/usernames.wireshark/hosts. So it's going to be a little bit different. You can actually look that up and reference that in the Wireshark help documentation. Of course, I have it on the screen here for you as well. So definitely note that down because it is going to vary based upon your operating system. And of course, we only showed it here in Windows. Now, I do quickly want to show you one other little trick Wireshark has up its sleeve in terms of manual name resolution. And I use manual because we're talking about manually applying a name mapping to an IP address outside of a mechanism like DNS that would pick that up automatically. Now, we could edit the host file, and that's one way to do this. But there's also another way which achieves essentially the same result. So we're looking at our packet capture here, and we see we have marketing 4 and we have ESPN, which we've already identified. But let's say we want to take this 4.2.2.1 address and we want to actually manually resolve it to something as well. Now, I could go ahead and edit my host file and then reload the capture file. But another strategy here is to right-click this IP address and say Edit Resolve Name. Now, when I do that, you see it's going to pop up a toolbar up here, and it's going to have that address selected in this drop-down menu. So I can actually go here, and I'm going to go ahead and just name this external DNS because I know that 4.2.2.1 is an external DNS server. So I do that, hit it OK, and it's going to automatically apply that resolution without having to reload the file, which is pretty helpful. It comes in handy if you've got a really large file and it's taking up a lot of memory and you don't want to have to wait for that whole process to go down. So we've done that, and that works pretty well. Now, in this case, if I just were to close this file without saving it, that information would be lost. But because I'm using a pcapng file now, so it says http://espn.pcapng, I can actually save this, and this information will be stored with the file. So it's not actually having to reference the host file, it's actually stored in the metadata of the pcapng file format. Now, keep in mind, this is only for pcapng. A normal PCAP file with a .pcap extension has no ability to store name resolution information with it. So it's something that's only a function of PCAP-NG. I can do this with a PCAP file, but when I close it and open Wireshark back up, that information is going to be lost. Here, I can save this information just by going to File Save and close Wireshark out. And when I open this file back up, we'll see that the information is still there. So we still have marketing for an ESPN coming from our host file, and we have external DNS coming from the manual resolution we applied that's stored in that file data. So a lot of ways to get to your end result here in terms of mapping IP addresses to domain names. We can do that with DNS information that's contained within the packet capture. We can send out packets to manual DNS, or excuse me, automatic DNS resolution by generating traffic on the wire, although that's not usually recommended. We can use a host file, or we can do manual resolution. So all different means to the same end, but very powerful feature nonetheless. So I can't stress enough how valuable name resolution can be, but you also need to be aware of how it works, when it's good to use it, when it's not good to use it, and the analytical pitfalls it can take you down if you make assumptions about it. So be careful of that. Be mindful of how far abstracted you are from the data, because with any analysis, the level of abstraction you have from the data is critical to understanding areas where bias can creep in and where your answers might end up taking a wrong turn based upon wrong information. So pay attention to name resolution. It's quite important, probably one of the more important features you'll learn about within the context of understanding Wireshark.